The final topic in section 3 will be joins and merges. And a join and a merge is an operation that refers to combining rows from different tables based on a related column. So that means that all of the tables that we'd be joining would hold a specific column, or sometimes referred to as the key column, that join would be applied based off of. Now, there's many types of joins out there, and PyKX covers all of these. And if you want to see all the different types of joins, go ahead and look in the PyKX documentation. You have the option to try the joins with PyKX native joins, as well as Pandas-like API joins. So depending on your preference or your use case, both of these options are available to you. Now today, we're going to be looking at an as-of join. And the reason we're going to look at this is because it's the perfect type of join to use with time series data. Now, an as-of join matches rows from one table and another table based on a key column, a shared column between the two tables. But often with an as-of join, that key column will be the timestamp column. And what happens is, when you're doing this joining of the rows, it's not actually based on an exact match of the timestamp. It can be based on an exact match, but if there is not an exact match, the join will be completed based on the nearest preceding timestamp. So when there's not exact matches, an as-of join is the way to join time series data. Now, it's really useful in situations like with working on capital markets data or trading data, where you want to combine data from tables that don't necessarily have exactly matching timestamps. Like if you were to be joining a table with trades data and a table with quotes data, those timestamps won't always match. So an as-of join is a great way to join these tables. So let's run this merge here and we'll evaluate the results. So we see first the column that we're actually doing the join on, which is the timestamp column. So this has all the timestamps that are in the Bitcoin table, as well as the corresponding row for that timestamp. And we can see in the column names that all of these columns here are the Bitcoin data. But as we scroll over, we'll see that we also have all of the column names for our Ethereum table as well. So within this table that was created by merging our Bitcoin and our Ethereum together, we have shared timestamps that will have the row for the Bitcoin as well as the matching row based on timestamp for the Ethereum data. Now, because the Ethereum and the Bitcoin actually do have exact timestamp matches, this is very easy. However, with our merge as of, you can see the potential for if the Bitcoin and the Ethereum dataset did not have exact matches in their timestamps, this would be a really easy way to still do an approximate match based on timestamp by taking that closest preceding timestamp from Ethereum and joining that to the timestamp from Bitcoin. So this is an as-of merge in PyKX. You can read more about this in the documentation. So with that, this will conclude section 3. And now that we are complete, you can go and take the section 3 quiz and then move on to section 4. See you there.